Hello, good people. Once again, this is Jonathan. I welcome you. We have yet another problem here, and it reads, in the following, I is the n by n identity matrix. If A, B, and C are n by n invertible matrices, does the equation C inverse into A plus x by B inverse equal to I have a solution x? If so, find it. In other words, that part A is just trying to ask us to solve for x. That's it. And part B is saying if M is an n by n matrix such that m cubed is equal to 0, show that the inverse of that bracket is equal to I plus m squared. All right, so let's tackle this one. So let's start off with part A. Now, let's rewrite it as it is. As it is given, guys, we have C inverse into A plus x being multiplied by B inverse equal to the identity matrix I. So we want to solve for x. So we have to be patient with this type of questions, guys. We have to solve it slowly and step by step. We don't have to rush things. So if you look at this statement, you can see that we have C inverse and B inverse. So first of all, I want to multiply this entire equation, both on the left hand side, on the right hand side, with matrix B. And if I do that, I'll have something like this. C inverse into A plus X, B inverse times B. The position where I place the matrix that I'm using to multiply is very important, guys. If I'm multiplying here at the back, I should have the matrix B multiplying at the back of whatever is on the right as well. I shouldn't have BI. Alright? The order does matter when it comes to matrix algebra. Alright. So I placed B behind B inverse, so I should place B behind I on the right hand side. So as you all know, both are invertible matrices, so the inverses exist. So B inverse times B becomes the identity matrix. So let's write the result of B inverse times B. So everything comes back as it is, and we have the identity matrix equal to, so the identity matrix times any matrix is that matrix. Okay, the identity matrix, it does not alter. If you multiply it to any matrix, it does not alter that very matrix. Okay, so it comes back as it is. Now I can simplify further. Before I multiply by C, I can simplify this further to C inverse by A plus X equal to B. Why did I do this? The I is gone because the identity matrix times any matrix will be that matrix. It doesn't change anything when I'm multiplying. So I times anything is that thing. So I times the entire C inverse times A plus X will come back as C inverse A plus X, like that. Now I want to multiply by C both sides. So I'll place C in front of C inverse. The order does matter, guys. Then A plus X, like that, equal to, since I placed the C in front of C inverse, I should have C in front of B. This is not equal to BC, okay? Don't make that mistake. Now C times C inverse will always give me the identity matrix. The multiplication of a matrix and its inverse will give you the identity matrix I. Then A plus X equal to CB. Now I times, remember, the identity matrix times anything will be that thing. So with on the left hand side we have matrix A plus X equal to CB. Okay, and now I can move things around and make X subject. Okay, I think this was the required solution, right? Show that Oh, it wasn't sure. It was just solve for x. All right. So this is the answer, guys. CB minus matrix A. Okay. So lastly, let's tackle this other part B. It's saying we need to show that. Okay. Let me just briefly write the problem here. We need to show that I minus M inverse is equivalent to I plus M squared, given that M cubed is equal to 0. Now, look at this statement, guys. You can clearly, we all know from matrix algebra that I minus M inverse is the inverse of the matrix I minus M. Okay, if I multiply these two, I minus M inverse times I minus M, I should get the identity matrix. But in this statement here, we need to show that the I inverse is equivalent to I plus M squared. So in other words, let's take I plus M squared and multiply it to I minus M and see if you get the identity matrix. If we can get the identity matrix, then we say, okay, then I plus M squared is also another form of the inverse. So let's see. So we want to check I plus M squared. If we multiply this to I minus M, if we get I as the overall answer, then we can say, oh, indeed, this I plus M squared is the inverse of this guy, because already we know that its inverse is this guy. All right, so let's do the multiplication. It's simple multiplication, guys. I times I, we remove brackets. I times I gives us I times I. Let's not write I squared, otherwise it will be a little bit confusing. And then I times minus M becomes minus I times M. And M times I becomes positive M dotted to I. And M times minus M is minus M by M. We will simplify in the next stage, but for now let's write it as it is. And then plus M squared times I, we have plus M squared times I, and lastly M squared times minus M is minus M squared times M. So if we simplify stuff here, I times I, remember the identity matrix will never alter anything, so it will be just an I minus I times M, it will be matrix M. All right, and then I times M will be just matrix M again, and then minus M times M, I can write it as M squared, it's fine. Then M squared times I is just a plus M squared, and then minus M squared times M, it will be minus M cubed. All right, so you can clearly see, guys, that these quantities, they cancel each other out. M minus M plus M 0, M squared minus M squared plus M squared 0, and M cubed, we are told in the question that M cubed is 0. So therefore immediately you can conclude that this result, the result of this multiplication will be an I. Thus we can conclude now, thus I plus M squared is also the inverse of I minus m, and so I minus m inverse is equal to I plus m squared as required. Full stop. Alright, I hope this is clear. Thank you guys for paying attention. Thank you for following. Bye for now.